Hello, today we are going to discuss about velocity of a transverse wave, and we will derive the equation for the velocity of a transverse wave. Now let's consider we have a string having length L and mass m. So the mass density of the string is mu is equal to mass per unit length. Now consider this string and we produce a single pulse in this string which travels with velocity v in this direction. Now we are going to calculate the velocity of this wave. For calculating the velocity of this wave, we will need to solve two equations. One is the net force equation for tension and the second is the centripetal force equation. Now let's consider this whole pulse and consider a very small length from this arc and we call that length del S. By taking this small arc length, we constructed this geometry where this is the center point and this is theta 1, this is theta 2 and this theta is equal to theta. Now remember one thing, when the velocity, when this wave is moving with a certain velocity in this direction, then the string is not moving, only the wave is moving and the string is just vibrating from a central point. For example, when the wave is going in this direction and due to tension T, it comes down, the tension T provides the restoring force to this place. Now consider this point here, and the forces acting on this point is tension T1 which is in this direction and the second one is the tension T in this direction. Now the forces acting on this arc length here are the tension forces in this direction and the tension forces in this direction, and by constructing this triangular shape we will calculate the components of this tension forces in the x direction and in the y direction. Now remember one thing, in the x direction there are zero forces which are the cos theta forces which is in this direction and another force which is in this direction balance each other and cancel out, but the y axis forces is the restoring force due to which this point comes back to its initial position. So the tension T forces provide these restoring forces, only the y component of tension T. Now this is theta. If we consider this theta and construct this triangle, then we have the y component of this tension force is T sine theta, and similarly for this side we will have the y component of this tension T is equal to T sine theta. So the F net force acting here on this point is equal to T sine theta plus T sine theta, which becomes 2T sine theta. Now here we did an approximation that sine theta is nearly equal to theta when the angle is very small. For example, this point is very far away, then this theta will also be very small. Similarly, this angle theta will be very small, and when this theta is very small, then we can say sine theta is nearly equal to theta. So we have F net force is equal to 2T theta. This is equation number 1. Now let's calculate the centripetal force, which is also a restoring force, and we know that the centripetal force is equal to mv square divided by r. Now F is equal to ma and acceleration is v square divided by r in centripetal force. So we have centripetal force is equal to mv square divided by r. Now we will determine the value of mass m and then we will substitute that value in this equation. Now we know that mass m here from the mass density of the string, we know that mu, which is the mass density of the string, is equal to mass per unit length or m divided by L. Now solving this equation for the value of mass m, we will get m is equal to mu times length. So we have mass m is equal to mu time the total arc length of this arc, which is denoted by del s here. Now we need to calculate the value of this del s. We know that s is equal to radius times theta. Arc is equal to radius times theta. Now here we have the total del s, which is the length from this point to this point, is divided into two small arc lengths. This is s1 and this is s2, and both of this s1 is equal to s2. So we have this total length del s is equal to s1 plus s2, and s1 is equal to s2. Both are equal because these triangles are equal on both the sides. So we have s1 plus s2 is considered as 2s, and we know that s is equal to 2r. S is equal to r times theta. Now the radius in this case here is this denoted by capital R. So we have del s is equal to 2r theta. Now we will substitute the arc length del s value 2r theta in this equation, and substituting the values here in the mass density equation, we will have mass m is equal to mu time 2r theta. Now we know the value of mass m. We are going to substitute this value in the centripetal force equation, which is Fc is equal to mv square divided by r. Substituting the value for mass, we will get mu 2r theta v square divided by r, and this capital R here will cancel out with this r. Both are radius the same, denoted by capital R. So we will have the centripetal force is equal to mu 2 theta v square, and centripetal force here is also an restoring force, which is equal to the F net provided by the tension T in the string. So we have the F net provided by tension T in the string is equal to 2 t theta, which is equal to the centripetal force and mu 2 theta v square. F net is equal to Fc, and 2 t theta is equal to mu 2 theta v square. Now these two will cancel out with this 2, and this theta will also cancel with this theta, and we will get t is equal to mu v square. Now solving this equation for velocity v square, we will get v square is equal to t divided by mu, and taking under root on both the sides of this equation, we will have velocity v is equal to under root t divided by mu. Now here t denotes tension T in the string, and mu is the mass density, and the mass density is equal to mass per unit length of this string. So substituting back the value for mu, mass per unit length, we will have velocity v is equal to under root t divided by m by L, which becomes under root t multiplied by L divided by m. Now if we know the tension T in the string, the length of the string, and the mass of the string, we can easily calculate the velocity of a transverse wave in a string. That's it. Thank you for watching, and do not forget to subscribe easyedu for more.